Carbon Report 2026. Spinach Garden. This report presents the calculation of emissions and sequestration for a 1,000 square meter agricultural plot, comparing Plot A, baseline, with Plot B, spinach garden. Plot A, baseline. Water system inefficient, heavy pumping right pointing arrow emission approximately 51 kilograms CO2e per year. Degraded soil, low organic matter right pointing arrow emission approximately 150 kilograms CO2e per year. Open land, low canopy cover right pointing arrow emission approximately 300 kilograms CO2e per year. Heavy use of chemical fertilizer right pointing arrow emission approximately 612 kilograms CO2e per year. Full chemical usage, herbicides, fungicides, insecticides, right pointing arrow emission approximately 200 kilograms CO2e per year. No burning right pointing arrow emission equals 0. Water bodies unmanaged right pointing arrow sequestration approximately equals 0. Right pointing arrow net balance, plus 1,313 kilograms CO2e per year, net emission approximately 1.3 tons per year. Plot B, spinach garden. New water system, pumping only 3 days per week times 15 minutes right pointing arrow emission approximately 7 kilograms CO2e per year. Water bodies 160 SQM, dredged 30%, 70% dense reeds right pointing arrow sequestration approximately 29 kilograms CO2e per year. Intensive soil improvement 50 SQM, organic matter plus pit model, right pointing arrow sequestration approximately 700 kilograms CO2e per year. Tree canopy cover approximately 80%, large trees plus 11 peacock trees, right pointing arrow sequestration approximately 8,560 kilograms CO2e per year. Fertilizer use reduced to 1 kilogram per week right pointing arrow emission approximately 338 kilograms CO2e per year. No chemicals right pointing arrow emission equals 0. No burning right pointing arrow emission equals 0. Right pointing arrow net balance, minus 8,944 kilograms CO2e per year, net sequestration approximately 8.9 tons per year. Key differences. Plot A represents the conventional system, chemical dependency, degraded soil, inefficient water use, and low canopy cover right pointing arrow net emitter. Plot B represents the ecological system, no chemicals, no burning, improved soil, efficient water management, and strong canopy cover right pointing arrow net carbon sink. Strategic conclusion. Even with only 1,000 square meters, comprehensive ecological management can transform a plot from a net emitter into a powerful carbon sink. For academics, this is verifiable evidence. For business leaders, this is a tangible ESG model that demonstrates how small-scale investments can yield high environmental returns. Raw data used in calculations. Total area, 1,000 SQM. Water bodies, 160 SQM, dredged 30% equals 48 SQM, dense reeds 70% equals 112 SQM. Improved soil area, 50 SQM, organic matter plus pit model. Canopy cover, approximately 80% of area, 800 SQM. Tree species, rain tree, jamun, bamboo, mature in 2022, plus 11 peacock trees, mature end of 2025. Water pumping, 3 days per week times 15 minutes. Fertilizer use, 1 kilogram per week right pointing arrow 52 kilograms per year. Average emission factor for chemical fertilizer, approximately 6.5 kilograms CO2e per kilogram. Plotter emissions, water 51, soil 150, canopy 300, fertilizer 612, chemicals 200, burning 0 right pointing arrow total approximately 1,313 kilograms CO2e per year. Plot B emissions plus sequestration, water 7/29, soil 0 700, canopy 0 8,560, fertilizer 338, chemicals 0, burning 0 right pointing arrow net minus 8,944 kilograms CO2e per year.